Welcome. Next, we are going to study relative extrema of functions of two variables. This is one case where increasing the number of variables makes the process much more complicated and also requires somewhat new techniques. I will say something about this at the end. For now, we will just stick to two variables. Absolute and relative extrema are defined more or less the same way as we did in the case of one variable. If we have some function f defined over a region R, a point x0, y0 in that region is called the absolute minimum of f over that region. If f evaluated at that point, that is to say f of x0, y0, is less than or equal to the value of f at any other point in that region. If f of x0, y0 is at least as large as the value at any other point in that region, x0, y0 is called the absolute or an absolute maximum. There might be more than one. A relative minimum or a relative maximum is one which is a minimum or maximum if you look only near that point. So more formally, x0, y0 is a relative minimum if f of x0, y0 is less than or equal to f of x comma y if x is sufficiently close to x0 and y is sufficiently close to y0. As we did with one variable case, we make the assumption that f is defined for all such x comma y. So f is defined in some square or circle around the point x0, y0. If f of x0, y0 is bigger than or equal to f of xy whenever x is sufficiently close to x0 and y is sufficiently close to y0, then we say that x0, y0 is a relative maximum. Suppose that I take a function f with partial derivatives and x0, y0 is a relative extremum of that function. Now if I keep y fixed and let x vary, then I have a function of a single variable and x0 is a relative extremum of that function of one variable. So from chapter 13 we know that the derivative is 0. By definition, this derivative is the partial derivative with respect to x of f at the point x0, y0. So we see that fx of x0, y0 is 0. By similar argument, fy of x0, y0 is 0. So in other words, at a relative extremum, the first order partial derivatives must be 0. To avoid rather extreme complications, we'll assume that our functions have continuous first and second order partial derivatives. In that case, we define a critical point to be a point where the first order partial derivatives are 0. So relative extrema are critical points with this definition. This part works for any number of variables. At any relative extremum, all the first order partials are 0. And these are the only places where we need to look at if f has continuous partial derivatives.